विकास यहाँ पे कौन लाया है? विकास यहाँ पे कौन लाया है? गुड इवनिंग रोहित।
Good evening, sir. Sir.
Yeah, good evening.
Good evening, sir.
Okay, Rohit, am I audible today?
Yes, sir, you're audible today.
Okay. Yesterday, I don't know why my laptop was not picking up voice. So
Sir,
that's why.
Sir, today we have physics, no?
Yeah, today we have physics.
Yes, sir. Sir, actually, from the NCERT textbook, Kepler's laws have been removed.
Yeah, I know.
Yes,
Since
sir.
we are working here as a competition. Okay.
Sir, should I just keep them in mind before the exam then?
Yeah, yeah.
Okay, sir.
Okay, so I think everyone has only Rohit has joined. Okay. Just wait. I have messaged everyone to join.
Good evening, sir.
Yeah, good evening. Good evening, Yukta. Just wait for one more minute. Start. Okay, let's continue. Now I think we can continue.
Yes, sir.
Okay, so we were doing the laws of gravitation and we had done the universal law of gravitation, right?
Yes, sir.
So for we have done here universal law of gravitation. So in the last class we stated that the force between any two masses.
So the
We
force
said that.
between any two masses attracts uh, other objects towards them, other masses towards them.
The force between any two masses is directly proportional to the product of the masses and inversely proportional to the square of distance between them. So what we can see according to this, the force of attraction between any two masses, as you know that the
The
law
force
of
is proportional to 1 by d square.
yeah
So we can say force is proportional to m1 m2 by d square.
yeah. So we had obtained here that if you have two masses, let's have this mass as m1, here you have another mass m2. The masses are being separated by a distance r. So the distance between them is r. We take this as r. Let this be your mass m1. Let this be the mass m2. So the force of attraction between the two masses, that is F, will be proportional to. So the last class we did F proportional to m1 m2 over r square. So we get F proportional to m1 m2 over r square. So force is directly
Sir,
proportional.
and to make it equal,
Yeah.
we can
Now
do
if
force is equal to G m into capital G into m1 m2 by r square.
yeah. So this in the last class we had studied up to the proportionality, right? And we
Sir,
had
I have a
seen
doubt.
how a variation in mass will cause a or will create a change in its force.
Sir,
Yes.
is it necessary to use R or do we use D?
See, D has a different meaning, so that's why it's better to use R.
Okay, sir.
So if you remove this proportionality, we get a constant. So we can write F equals
The
to
universal gravitational constant known as capital G into m1
m1
m2 over
over
r
r
square.
square. Okay. So the value of this capital G, this
There it's
capital
6.67 into 10 raised to minus 11, and it was deduced by the English scientist Henry Cavendish when
yeah.
he
So
was
this cap
performing an experiment of yes, sir.
this capital G is it is equal to
6.67
6.67
into 10 to the
times
power of minus 11
minus 11
Newton
Newton
meter
meter
square
square
per
huh,
kg square.
per kg square.
Sir, or it can also be Newton meter square kg minus 2.
Okay. Harshit, welcome to the class.
Yes.
Okay. So please keep joining on time. Okay. Join the class on time. So, see, we observed that the value of the universal gravitational constant That is capital G is 6.67 multiplied 10 to the power minus 11 Newton meter square per kilogram square. So this capital G, it is also called as universal gravitational constant. So we call this GH. This G is universal gravitational constant. So this G, it is also called a universal gravitational constant.
Gravitation constant.
Why it is called a universal constant? As it can be applied anywhere in the universe.
Yes, sir.
The value of G, it holds for any value or any place in this universe. Okay. And its value remains the same. So that is why it is called as a universal gravitational constant G. The value of this is 6.67 multiplied 10 to the power minus 11 Newton meter square per kilogram. Now see the problems or the questions involving this gravitation. Okay. So to solve the questions involving this gravitation, one must be very well aware of the scientific notations and calculations involving scientific notations. Okay. So just I will give you an idea of the scientific notation, then we will do the questions based on it.
Yes, sir.
Alright. So see, first of all, how we are going to operate in the scientific notation. If you are aware of the scientific notations and calculations in the scientific notation, then this formula will be easy for you. You can easily apply. See what all things will be there. So first of all, conversion of units. Conversion of units will also be written in terms of powers. Like suppose I want to convert 1 gram to kilogram. So 1 gram to kilogram will be equal to 10 to the power minus 3 kilograms. You have to write it like this. If you are given 1 centimeter, so 1 centimeter will be written as 10 to the power minus 2 meter. Or if you have 1 millimeter, so 1 millimeter will be equal to 10 to the power minus 3 meter. Got this?
1 second, sir. Just noting it down.
It's the same mathematics which you have been doing up to now. Like 1 centimeter can be written as 1 over 100 meter. So 1 over 100 can be written as 10 to the power minus 2. One if you have 1 millimeter, so it can be written as 10 to the power minus 3 meter. Then the same occurs with the larger values. So we'll solve one question relating this and just observe how the force is being calculated, how we are using the scientific notations and everything. The calculation will seem very tough to you, but once you go through the scientific notations and its calculations, it will appear to you easy. So let's see how it happens. Arshit, when are your exams?
Sir, sir, actually they are going on.
They are going on. So when do you have your science exam?
Sir, it could be on next week.
Next. Okay. So this is gravitation. I just want to show the question.
Sir, I think on this month 30th.
What happened?
Sir, I think my science is on this month 30th.
Okay, and this month you have your exam on 30th.
Yes, sir. Yes, sir.
We'll see a few questions here. Just see this question. Example, this one. See, the mass of Earth is 6 into 10 to the power 24 kilogram, and that of the Moon is 7.4 multiply 10 to the power 22 kilogram.
Sir, easy. I already solved this in. Sir, can I solve it and give you the answer?
Yeah, please solve it.
Yes, sir. Sir, it's 3.84 into 10 to the power 5, no?
Yeah, 3.84 into 10 to the power 5 kilometer. So all of you just write down the values which are given. We write here mass of Earth as m1, which is 6 multiplied 10 to the power 24. We write it as m2, which is
7.4 into 10 to the power 22 kg. Sir, distance between Earth and Moon is 3.84 into 10 to the power 5.
so distance r is given as 3.84 into 10 to the power 5 kilometer.
Sir, force is equal to G m1 m2 upon r square.
So what you have taken r as?
Sir, G is 6.67 into 10 raised to minus 11.
How much?
Sir, R will be 3.84 into 10 to the power 5 whole square.
No, r will be 3.84 multiply 10 to the power 8. This will be 10 to the power 8 meter, since it has to be taken in SI unit. Okay. So you'll take it 3.84 multiply 10 to the power 8 meter. Now solve it. A kilo means 10 to the power 3. Okay. So you are converting from kilometer to meter. So they have to multiply it by 10 to the power 3. And if you multiply it by 10 to the power 3, you get 10 to the power 8.
Sir, won't it be minus 3, 10 to the power minus 3?
Hmm?
Nothing, sir. Sir, it will be 10 to the power, it's 10 to the power minus 3, so won't it be 10 raised to 2?
No, 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 no. You are going the wrong way. This was the conversion we have written.
Sir, it's
1
10.
centimeter to meter is 10 to the power minus 2. Okay, just see the step by step how we go. See, 1 centimeter can be written as 1 over 100 of meter. So this I can write it as 10 to the power minus 2 meter. Similarly, 1 over 1000 meters can be written as 1 over 10 to the power 3 meter, which can be written as 10 to the power minus 3 meter.
Yes, sir, that's what I'm saying, sir. Won't it be 10?
If 1 kilometer will be equal to 1000 meter, so this will be written as 10 to the power 3 meter. Alright?
Okay, sir. So 10 to the power 8.
Yeah. So obtain it, you have to write F equals to G, which is 6.67, multiply M1, which is, sorry, G is 6.67 multiply 10 to the power minus 11, multiply M1, which is 6 multiply 10 to the power 24, multiply M2, that is 7.4 multiply 10 to the power 22. This whole divided by R square. The value of R is 3.84 times 10 to the power 8. Now you square this. Okay, see. So Rohit and Harshit. Harshit, can you solve it further?
Yes, sir, we can. Sir, it becomes 3.84 into 3.84, which becomes 14.7456 into 10 to the power 16, because 8 into 2.
Okay, here
So then
we will.
we do 6.67 into 6 into 7.4.
See, somewhere we will be using some approximation to find out the answer. Okay, we
Yes, sir.
won't ever be using exact values since we are not using calculator. Okay,
Yes, sir.
so see where all we can do such kind of things. I will do this question in front of you also without a calculator and with very little effort. So first of all, we collect only the numbers. Okay, whatever are 10 to the powers, we keep them on other side. So I collect here 6.67 multiply 6 multiply 7.4. These are the numbers. In the denominator, you have 3.84 multiply 3.84. About the 10 to the power, here you have 10 to the power minus 11 multiply 10 to the power 24 multiply 10 to the power 22. Okay. Divided by the denominator would be 10 to the power 16. As when there is a power of power, so the powers get multiplied. Got it? Any doubts here? Yeah, any doubt?
No, sir.
Okay. So see, I will try to approximate a few things and then find out the answers. Since I'm not using a calculator, so I need to do such things. First of all, this whole can be found out easily. I can reduce this whole fraction into a simple, at the positive powers, and here it's 3.84, so you can just write it as 3.8. Okay, and you can see if you multiply 3.8 times 2 or 3.8 plus 3.8. Okay, so you get approximately 7.6. Are you getting?
Sir, what?
Okay, you try to solve it and see how I'm solving. Instead of considering 3.84 and increasing my calculation, I just remove this 4. I'm rounded it off. So by rounding off, I got it as 3.8. In the similar way, I can round the numerator also, like it's 6.6. So I can round it as 6.7. So you can cancel this 3.8 and 7.4. Cancel this and see what do you get.
Okay, sir.
And about the 10 to the power, we get here multiplied with 10 to the power negative 11
Sir, we get
plus
10 to the power 35.
plus 24 plus 22 minus 16. So this is 10 to the power 35. Are you getting 10 to the power 35?
Yes, sir.
Okay. It becomes, you can write, add them, so it becomes 46 minus 21, right?
Sir,
And 46
18.
minus 21 is 10 to the power
7.
35.
Yes, sir.
Okay. So this one is clear. What about this? Solve this part now. Okay, what approximately you get if you multiply 6 and 6.67?
Sir,
Yeah, anyone, what do you
6.7.
get?
Sir, 1 second. So we get 40.2.
Is it 40.2? Yeah.
Yes, sir, 40.2.
Okay, so you multiply it 6.67 multiply with 3 point, okay, multiply with 6, you get 40.2, 40.02, sorry. So you can just take it 40, multiply it with 7.4. Fine. Just solve this portion and you will get the answer.
Sir, won't it be 40.2?
No, it's 40.02. You can recheck. Hmm? Yeah. Raise your hand. 40.02. Okay, so multiply it and then solve.
Sir, we get 40.2, sir, I calculated it.
Okay. When what do you get if you multiply 3.8, 3.8?
Sir, 14.44 approximately.
40 point?
14.44.
Okay.
Sir, 14.44.
Yeah, you can get 1.4 divided by 14.4. And here you get multiplied 10 to the power 35. So you just solve this, you get the answer. So you saw here that you must be aware of the scientific notation, how to use them and where to use them. The next we have one more question. Let's try this one.
Sir, we shouldn't solve it more, right, if it's not divisible?
No, you should solve it. You should solve it further completely. Hmm, that's what, I'm just moving on to the question of gravitation. Okay, so try this one. What is the magnitude of the gravitational force between the Earth and a 1 kilogram object on its surface? Mass of the Earth is 6 into 10 to the power 24 kilograms. And radius of the Earth is 6.4 into 10 to the power 6. But try this one.
So you think you have to find the small G or the big G?
Yeah.
Then can you explain this question also? Sir, can you please explain this question?
Sir,
Hmm.
1 second, sir. Sir, will the sir, will mass 2 be 1 kg only?
Yeah, mass to be 1 kilogram.
Sir, and radius will be r square, no?
Yeah, radius will be r square. So what is the radius?
Okay.
That will be equal to the radius of the earth.
Sir, so radius is given in meters already. Yeah, sir. So we can
Yeah,
just
radius
solve
is given here in
properly.
meter only.
Sir, and the value of capital G 6.67 into 10 to the power minus
Yeah,
7.
value of capital G is constant. That's 6.7 into 10 to the power
Yes, sir. Got it.
minus 11. Okay, so did you get the answer?
Sir, solving. 1 second, sir.
Yeah, solve it. Harshit,
Yes, sir. I didn't understand this question.
you didn't understand.
Yes.
Use the formula F equals to G M1 M2 over R squared.
Sir, do we take 6.67 and round it off to 6.7?
Which one?
Sir, can we round off 6.67 to 6.7?
Yeah, you can. Yeah, so did you get the answer?
So 1 second, calculate.
Sir, I got 40.2.
Okay, you got 30.2.
No, 40.2 upon 40.96 into 10 to the power of 12.
No. See, what you will be getting your answer will be equal to 9.8 Newton.
Sir, 9.82.
9.8 Newton, that should be your final answer.
So 9.8 Newton.
Just check it, your answer should be 9.8. Did you get it?
Yes, sir.
Just check your calculation. So we obtain this F as C.
Oh, okay, sir. I got it.
Multiply M1, which will be the mass of Earth.
Yes, sir.
That
Yes,
is
sir.
6.
Yes, sir. 1 second for you.
Multiply 10 to the power 24. Multiply M2, which will be 1. This divided by r square, which is 6.4 multiply 10 to the power 6 meter. So square. So if you solve this, the final answer you should be getting as 9.8 meters. So this should be the final answer. Okay, let's say this question. Let's say question number 4. The Earth and Moon are attracted to each other by gravitational force. Does the Earth attract the Moon with a force that is greater or smaller or the same?
Sir, can I
So
answer this?
Yes?
Sir, it's the same because Newton's third law states that every action gives an equal and opposite reaction. So the gravitational force exerted by the Earth on the Moon is the same as the gravitational force exerted on the Moon as the Earth. So it's the same.
Yes, that's correct. That's correct. Now see this one. So both the objects, the Moon and the Earth, they both are attracted with the same amount of force. Okay, then fifth one, if the Moon attracts the Earth, why does the Earth not move toward the Moon? Yes, why does the Earth
Sir,
not
because
move?
the sun exerts a very heavy gravitational force on the Earth. Is that the reason?
Yes, what happened?
Sir, it is this because the sun exerts an heavy force on the Earth. That's heavy gravitational force on the Earth. That's why it does not move towards the moon.
See, both of the masses, they have the same amount of
Same
force.
amount.
Okay. And they are not moving towards each other because whatever is their force, that is being used up as a gravitational force.
Okay, sir, I understood.
You got it? Let's
Sir,
see the
so
next one.
the answer is the same as answer 4, but we just say that the gravitational force is being used more between the two objects.
Okay, now see this question 6. What happens to the force between two objects if the mass of one object is doubled? So
So the
we had
force
done such a
becomes
question.
twice the object.
What will happen?
So the force becomes twice the object.
Force becomes, yeah, force also becomes
Twice,
the
twice.
twice.
Two
Yeah, it also
times the
becomes.
object. Yeah.
Okay, that's right. Then second one, the distance between the object is doubled and tripled.
So we have to split this into two. The first part will be double. So it will become 1 by 4 times the force. And for triple, it will become 1 by 9 times the force.
Yeah, so if it is doubled, the force becomes
1 by 4 times the force. And if it's tripled, 1 by 9 times the force.
yes. So that's correct. So the free fall and the weight, this we haven't done.
Sir, there's one more bit to the question, right?
Which one?
So the sixth one has one more.
Okay. So I think we have done, we are left with only a few questions which may which
Sir,
we'll be able to do once we get study the free fall and acceleration due to gravity.
sir, can
this-
you once more explain the third question? I'm not getting 9.8 as the answer.
Okay, just 1 minute. You will be getting somewhere 9.77 something or 9.776. Are you getting that thing?
Sir, when we do 6.7 into 6, we
Yeah.
get 40, right?
Yeah.
And so we get 40 by 6.4 into 6.4,
Yeah.
which becomes 40 by 40.96.
Yeah. Okay. And what is the 10 to the power here?
Sir, 10 to the power 24 into 10 to the power of minus 11 divided by 10 to the power 12, which will become 10 to the power 1, sir, right?
So which one is 10 to the power 1? So this one would become, we'll be able to write it 6 multiply 6.7 divided by
6.4
6.4 squared.
sir,
And here it should be 10 to the power 24 minus 11 minus 6.
minus 12. Minus 7 minus 12 becomes minus 23.
So minus 11 minus 6 is minus 17.
No, sir,
So
6 times 2, right? 12. 12, no, sir.
Yeah, sorry. It's 12. You get a
So
negative.
minus 11 minus 12 becomes 23 minus 23. 24 minus 23, 10 to the power 1.
Okay, so 10 to the power 1 is 10.
10.
So you can multiply 6 and 6.67.
6 into 67 by 6.4 into 6.4, which is 40.96.
Yes. Okay. Understood? So if you divide this, you are going to get 9.8.
Sir,
Are
we
you
get
getting?
402 by 40.96.
How much you get?
402 by
That's what-
40.96.
Yeah, 402 divided by 6.4. Again divide by 6.4. Yeah, you are getting 9.81. See? You are getting this as 9.8. Right?
Oh,
Okay.
okay, sir. Got it.
Okay, bye all of bye both of
Yes,
you.
sir.
See you again in next class.
Yes, sir.